Okay, so we're asked to write the family of equations for each equation below. So number 1, here's an equation. So rearranging that, we have p equals a minus m. We could have m equals a minus p. Obviously swapping those two around as well to add. A times b equals c, so a will be c over b, and b would also be c over a. These two must multiply together, so m equals n times p. And similarly we can swap those two around, so m divided by p must also equal n. If you're not sure about any of these, you could be using numbers just to check. So for example, 12 divided by 3 is 4. So from that I know that 12 divided by 4 is 3. And I also know that 3 times 4 equals 12. Right, some equations for this one. We could start with b plus f equals d. What about f? F is going to be d minus b. So clearly d is the larger term. Right, E equals mc squared. So working out c, e over m, and square root that to get c. What other formula? We could find m would be e divided by c squared. Right, number 6. Working out a would equal y divided by the square root of x. And working out for x, we need y divided by a, and then we need to square it, which is y squared over a squared. Right, number 7, what equation can we find? Well, if that's the area, we know that a times b equals 40, but we also know that a equals 40 divided by b, and b would equal 40 divided by a. Right, we've got a triangle here, so base times height divided by 2 is 40. We could get therefore that the base times the height is clearly 80. Working out for one of them, b would be 80 over h, the h would be 80 over b. That's how we'd get all those equations. Here's our trig formula. Obviously these two multiply together, so opposite equals sine theta times h. We can also swap these two round. O is the larger quantity on top, so h would equal O divided by sine theta. And you might remember too, if you wanted to find theta, you'd need sine to the minus 1 inverse of O over h. Sine inverse is the opposite to sine. Right, number 10, we're asked to find a relationship between a and b. Well, this is a trapezium, and I've got its area. So I remember that the area of a trapezium is a plus b times the height, which in this case is 6, divided by 2, and that has to equal 24. So if we're not sure what to do, let's start by multiplying by 2. And then we could divide both sides by 6. So there's a relationship between a and b. We can see that a plus b equals 8. And just check 8 divided by 2 is 4. 4 times 6 is 24, so that's right. Similarly, you could write b equals 8 minus a, and a equals 8 minus b. Right, number 11, find an expression for x in terms of a. So that means we want x equals. Right, it's a circle. So a equals pi times the radius squared. It's really important to put the radius in brackets because we want to square the whole 3x. So a would equal pi times 9x squared. Now we want x equals, so we need to rearrange this. We could start by dividing by 9 pi. So x squared equals a over 9 pi, and then x will be the square root. X is a length, so x needs to be positive, so we just want the positive square root of that. An expression for the circumference in terms of a only. Right, so the circumference is 2 times pi times the radius, which in this case is 3x, is the radius. Now unfortunately we want it in terms of a only, we don't want the x in there. So we need to do some substituting for x. So c is going to equal 6 pi times, now instead of x we could use that. There is some minor simplifying we could do from that, but we'll leave it like that. So now I've got an expression for the circumference based on the area. So if I know what the area is, I can put it into this formula and it will tell me the circumference straight away without having to work out the radius.